Okay, so we're going to go ahead and look at a couple of additional problems in section 4.2 where you have two events with the or in between. All right, so this is the first one. The question says, what is the probability that he or she is an orthopedist or an MD? So you want to key in on this word or, because that tells you essentially that you're going to be using one of these two formulas listed up here. All right, so remember that one formula is used if your events are mutually exclusive. One formula is used if your events are not mutually exclusive. And so to determine which one we got, we want to go to our data table. All right, so we want to look at the orthopedist, all right, which would be everybody in this row. Right, and then we want to, so that takes care of that. Then we want to look at the MDs. So that would be everybody in this column. And we want to look and see whether these two intersect. And so we can see that these 21 people right here are part of the MD group, the column, and they're also part of the orthopedic group, which is the row. And so these events are not mutually exclusive because you have these 21 people which overlap between the two events. Okay, so what I'm going to do first is I'm going to take that formula, that second formula, and instead of the A's and the B's, I'm going to write it out with the two events that we have, which is orthopedist and MD. All right, so let me do that first. So instead of A or B, I'm going to put orthopedist or MD. Okay, and my formula says, first I'm going to do them separately and put a plus in between. So that's going to be the probability of an orthopedist plus the probability of an MD. Okay, and then the formula says subtract off, and this is your overlap part, the probability of both things happening, and you put an and in between. So ortho and MD. Okay, so the first thing I'm going to do is I'm going to go into my table and I'm going to add up all of the numbers in the table. So 9 plus 8 plus 21 plus 5 plus 4 plus 3. And so that's going to give me 50. And so that will be the bottom number on all three of these fractions, because remember on the bottom it's the total number possible. Okay, so now all I have to do is go get the top number for each one. All right, so for the orthopedist, so I'm going to look at that orthopedic row and I'm going to add up everything in that row. So 21 plus 3 is going to give me 24. All right, for the MD, I'm going to add up everything in the MD column. So 9 plus 8 plus 21, that's going to give me 38. All right, for the last one, I'm going to look at the overlap. How many were in both groups? And we've already marked that as being the 21. We highlighted that in yellow. Okay, so 24 plus 38 minus 21 is 41. The denominator stays the same. The problem asked me to write it as a fraction in lowest terms, which 41 over 50 cannot be reduced. All right, so let's look at another one. So probability that the student is a male, and here's my word or, age 18 to 24. So I'm going to do the same thing. I'm going to check mutually exclusive or not. Okay, so I'm going to go to my chart. I'm going to circle the males. I'm going to circle the 18 to 24, and I'm looking to see if these circles intersect and have anything in common, and they do. They have this 7922, which makes this not mutually exclusive, which means that I want to use my longer formula. All right, so what I'm going to do here is go ahead and apply that formula with the events that we've got. So male or 18 to 24, we're going to do each one separate. So male, 18, 24, add it together, and then we're going to subtract off the overlap, just like we did in the last one. All right, so first thing I'm going to do once I get my formula written down is I'm going to go in and I'm going to add up everything in the table. So 79.22 plus 34.75 plus 21.53 plus 25.43 gives me 16,084. And remember that that is the number on the bottom for all three fractions. Okay, so now all we have to do is calculate the top part. All right, so probability of male. So what I want to do again is go in and add up all the males. So 79.22 plus 21.53. That gives me 10,075. All right, for the next part, I want to look at the 18 to 24, and I want to add that up. So 79.22 plus 34.75, that gives me 11,397. Okay, and then for the last part, we want the males and the 18 to 24, which are the ones that I initially marked in yellow. Those are the ones that are in both groups. So that's the 79.22. All right, so let's do our calculation there. All right, so I'm going to add across the top here, and then I'm going to subtract the 79.22. All right, so that gives me 13,550. Denominator stays the same. And I do need to reduce the fraction. Both of those numbers are divisible by 2, so divide the top one by 2. And divide the second one by the bottom one by 2. Right, and now we have a fraction reduced to lowest terms. All right, so the last one says that we want the probability that they drive less than 10,000 miles per year or they have an accident. Okay, so less than 10,000 miles per year would be here. Accident would be here. And again, we can see the overlap. So we know that the formula needs to be the longer version of the formula. Okay, I already have it written here on the screen. So we're just going to kind of jump in and do the pieces. All right, so remember that we start with each one separately. So less than 10,000 and then accident. So those are the separate pieces. And then we look at the overlap here, subtracting that off. All right, so if I add all the numbers in the chart, 15 plus 45 plus 30 plus 60 plus 45 plus 105, that gives me 300. So that's the bottom number for each of the three probabilities. All right, so let's look at the less than 10,000 miles. All right, so less than 10,000 miles, we would add the 15 and the 45. So that would give me 60. All right, next comes the accident piece. So that would be 15 plus 30 plus 45. That's going to be 90. And then we want the ones that meet both criteria, less than 10,000 and an accident. Those are the 15 that we initially highlighted as being in both. All right, so 60 plus 90, minus 15 is 135. Denominator stays the same. We need to reduce both of those fractions. So let's see, they both reduce by, let's see, maybe by 15? Yeah. All right, so 135 divided by 15 is 9. 300 divided by 15 is 20. Okay, so there's my fraction reduced to lowest terms. It also says in this one that you can do a decimal rounded to 2 decimal places. So you could also say 0.45. And you do want to pay attention on the problems as to how they want the answer written, whether as a fraction or a decimal, or if both are okay. All right, so hopefully that helps you with those types of problems where you're given that data set in a table form and you have to pull out the information that you need for the OR problems.